Hello, and since I plan on retiring at some point, I'm going to make a couple of meteorological studies that you guys can use later on, so you can do your own little weather prediction. This is going to be layers of the atmosphere and how it equates to H's and L's that are on weather maps, and how we know which one causes sunshine like we have today, and which one causes rain like we had a couple days ago when we had all those tornado warnings. Okay, so first we got to talk about layers of the atmosphere. I'm not going to really talk about the layers, but I'm going to say basically all weather happens in this bottom one, troposphere, where temperature starts out relatively warm and cools off, and pressures go from 1013 standard air pressure all the way down, and basically it goes down all the way, and these layers are actually defined as basically big temperature changes. So this one actually shows you standard air pressure. This is 29.92 inches of mercury. In other words, how much of mercury can the air actually hold up. Fill a container with mercury, fill a tube with mercury, stick it in a container, open up the bottom, and let it fall out until the air pressure equals the weight of the mercury, and it's 29.9 inches. It's also known as 1013 millibars. Here's a picture of sea level where you normally get 1013, although it's a little lower, and you can see that air pressure gets lower and lower as we go up, and that's due to the fact that most of the air molecules are down here, and it gets thinner and thinner as you go up. Here's a picture of a water bottle that a hiker actually drank, screwed the top on, drove down the mountain, actually looked at it and we have more air pushing on the inside. We closed it with air this dense, and there was more air outside here, so it pushed in the bottle, drove down to sea level, pushed in the bottle even more. So that's basically what happens. As you see, temperature as it goes down and temperature goes up, relative humidity, the amount of water that it's holding compared to what it can hold, 100% is as much as it can have, 0%, which doesn't happen in our atmosphere, is as low as it gets. 100% is all it can get. If it actually gets higher relative humidity, it's got to squeeze out in clouds. And as the air goes up, it cools. As temperature cools, relative humidity goes up. It reaches what's called the condensation level, and anything above that, you get clouds, condensed clouds. If the temperature is below freezing, like it is here in Virginia most of the year, these things are going to be made of ice crystals. If it's actually above freezing, like it is more or less in the tropics, these could be water droplets. Our snow, even in July, the ice crystals fall through warm air. They melt long before they get to the bottom, but if you've ever felt thunderstorm rain droplets, you can tell that they're cold. They probably weren't ice very long before it hit you. Lows, we've talked about counterclockwise swirls. Highs come out with a clockwise spin. It's caused by air moving down, feeling heavier, air moving down, feeling heavier, air moving up, getting lighter. Oops, I'm going the wrong way. So air heats up, it goes up, it feels lighter, so the number from 1013 or 29.92 inches, it's going to decrease, and then it's actually signified by an L, and we actually put concentric circles with like air pressure on the outside, and the H's are when cool air actually starts coming down and hits the surface, and usually that's higher than 1013 or 29.92 millibars, and usually with a blue H, red L, blue H, with again concentric circles with like air pressure. This is a pivotal weather picture, and you can see there's a low. This is where air pressure is going up. Instead of 1013, it's 995. There's a low with 998. The one we had earlier this week actually I think was like 970, and the lower the number, the faster the air moves up. The faster the air moves up, the faster the relative humidity increases. The lower the condensation level is, the thicker the clouds get, the more energy is in the clouds, and then that leads to stronger rain, hail, wind speeds, because wind always moves from high pressure into low. So the higher this is and the lower this is, the faster the wind moves between it, and we get storms. So this is a picture of actually 12Z valid for March 7th. This was actually taken today, the 12Z reading, so that's this morning, and you can actually take a look at the H's for highs, blue, where air is coming out, flowing in a clockwise direction, and L's for low pressure, moving in a counterclockwise direction. There's another low, although they're not showing it because the clouds, it's actually precipitating snow. Here's rain and snow. And then, so that's 101. I do want to go into pivotal weather, and I want to show you what's going on between today, the 26th of February, and 384 inches all the way to the 13th of March. And you can watch these lows and highs. You can see snow, you can see rain. The clouds are with the lows. Remember, counterclockwise spinning in, and the H is clockwise spinning out. H is usually higher than 1013, lows usually lower than 1013. This is not a very low low. This is a little bit lower of a low. That's a pretty good high, 29. There's a 27. And they just move across the country. They move pretty much from west to east. They ride the jet stream. Jet stream probably is swooping down like this. And they just move on. And if you take a look at the blues, actually let's just look at snow depth really quickly. Snow messes us for the next 2 weeks. Gets really close right there, although I think that's not going to be much. That's next Thursday. And then a little bit of light snow, and if you actually look at snow cover, it hits over here in the west for the Rockies and the Sierras. It hits north because it's cold and misses this whole section right in there. Really pathetic. Okay, so that's Meteorology 101A. Thank you.